It is my pleasure to introduce you today Stefania Druga, who is the speaker. Stefania is a Ph.D. candidate at the University of Washington in the Information School here in Seattle. She's passionate about studying AI, literacy, and the design of new creative coding platforms for children and parents. So there is a huge emphasis on the family in Stefania's work. She has a very interesting journey and experience. She was previously a LEGO Papert Fellow during her time as a master's student at MIT, working with Professor Mitch Resnick and the Scratch team, which maybe many of you know. She also did a summer internship at Microsoft Research and right now is doing a residency for AI and machine learning at Google X. So lots of interesting things to connect to Stefania. As in a personal note, I have met Stefania, I think in 2017 in a conference, and somehow we've been connected since then. Outside of work, Stefania is a very fun person to hang out with, and I'm absolutely happy to have her here today. So today the talk will be about creative coding with AI friends for youth, and I'm going to stop sharing my screen and give the floor to Stefania.
Oh, wow. Thank you so much, Patricia. And thank you, Miguel, Sylvia, Kush, and all the Talking Robotics organizers for the invite. I'm very happy to be here with you early morning on the West Coast. I'm calling in from Berkeley, but yeah, I'm drinking coffee, not matcha, although I love matcha. And hopefully I won't talk too fast. Feel free to interrupt at any time if you have questions. And I'm also going to leave some room for discussion at the end. So without further ado, I'm going to share my slides. 1 second. It was on the last slide. I didn't want to spoil the surprise. So let's see. Can everyone see my slides? Can you hear me? Awesome. Yes. Yeah, so today I'm going to talk about a myriad of research that I've done in the past years, both in terms of coding with children and families and also AI literacy. And I will center most of this discussion around this question of what does it mean to be active, like from creativity and activity in the space of programming with AI for youth. So for me, like, why does this matter? I think it's very important to see the computer not only as a form of being productive or as a form of automating tasks or really, increasing human productivity, but also to see the computer and programming as an extension, as an expressive medium that allows people to create new forms of art, new artifacts, and express themselves in unique and new ways. And I'm not the first one to think this. Actually, this quote here comes from Sherry Turkle and Seymour Papert. This is one of my favorite papers of all time, although it's older now, on epistemological pluralism. So even back in the 90s, Sherry Turkle, Seymour Papert, who created Logo, which inspired Scratch, we're seeing computers, we're seeing programming, not necessarily only as a form of getting jobs in tech or understanding computational thinking, but also as a form of personal expression. So there are a couple of existing projects that took this approach, and I wanted to highlight two. One is this work on Scratch microworlds from Moran Sur, who was my colleague in the Scratch team in the lifelong kindergarten group at Media Lab. So Moran really saw the opportunity of engaging youth in programming as a way of exploring their interest. So she created this space of like microworlds for Scratch where young people could learn programming while they're programming their own songs, or they are doing like fashion games, or they're programming dancing games or like dancing applications. So the idea was that it was that the entry to programming was through their interest and things that were most exciting for youth. In parallel, or like at the same time, Catherine Cunningham also did a lot of work. This is more recently published on purpose-first programming. So instead of like taking the approach that youth should learn about loops and functions and like what is matrix multiplication before we even talk about AI, she actually wanted to understand what is it that people want to learn, what is their purpose in getting interested in programming, and she designed an entire curriculum and approach for introducing newcomers to programming from purpose-first programming perspective. And there are some tensions between these two approaches, right? Like in the work that Moran proposed, for example, it's very generative. There's no right solution. Basically, in a micro world, it's like a tiny Scratch program. I don't know if people have seen Scratch, but it's this visual programming language where you have blocks similar to Lego blocks, but on the screen, they fit together, and you can recombine them in lots of different ways. There's no right or wrong solution. If they don't click together, then that means you can't connect them in that way. But you could have just 6 blocks and recombine them in lots of different ways. Like I could make 10 different guitar songs with these blocks, for example. In the purpose-first programming and in general in the instructionist tradition of programming education, there's much more this approach of like scaffolding, conceptual learning, but typically it's very much tutorial based. And for most of the programs that the newcomers are introduced to, there is a right solution, and people need to find that right solution. And this is more similar to how we actually teach programming in universities or in high school, where you would have like tests and problem sets, and either you get or the right solution or you don't, right? So these two approaches are quite different, and my focus is on creativity that is kind of formalized with the first approach. I would like young people, to explore programming in a very generative way. I think sometimes it can be quite frustrating if they're trying to build a project and there's only one right solution and they don't get it. People can get discouraged, or they can feel like, oh, this is not for me. I don't think in a mathematical way. I don't think in a technical way. When in reality, like if we think about how people learn, it's much more like tinkering, right? Like you try something, it doesn't work, but it leads to something else. So it's not necessarily a winner takes it all approach, but it's much more a tinkering and bricolage and playful approach to learning. So the question about creativity in programming system is like, how do we actually support, right? Like, what does it mean to program a game that is creative, for example, or an animation that is creative? Like, what does it take for a program that young people do to be creative? And if we actually take inspiration from Stravinsky in music, he says that the more art is controlled, limited, has constraints worked over, the more it is free. So if we look in the world of art, there are a lot of inspirational quotes and biographies and testimonies that show that having constraints is helpful. Starting with a blank page or starting with a blank program, like the cold start is called this in programming, it can be quite intimidating, like you don't know what to do first. And when I kept on using the C word, creativity, and there's a definition of creativity with so many definitions of creativity. Patricia actually wrote a paper last year trying to summarize and kind of present all the ways in which creativity has been defined and used in HRI, for example. And they're also on top of, like, we're not going to agree on a definition of creativity today, but I just wanted to put it out there that people define it in lots of different ways, as brainstorming, as lateral thinking, divergent thinking. And not only they define it in lots of different ways, they also measure it in lots of different ways. But we have things like affect in play scales, the famous Torrance test. This was one of the first tests that was highly recognized in terms of creativity measurement. And my focus in my work is actually on creative self-efficacy. So this is derived from Bandura's general concept of self-efficacy. And this basically means that I don't need to cast a judgment or a subjective evaluation of a child's program to say it's creative or it's not, but I want to create a system and an environment where the children themselves over time feel more confident in their creative expression. And they are the ones who get to evaluate if they were able to achieve like their goal, like were they able to express their ideas through code? How fluently were they able to express their ideas through code? So my focus in the work I'm doing right now of creative support and for programming for youth is on this notion of creative self-efficacy. And in terms of creativity support, there aren't direct related work for programming, but there are other projects that were done for different forms of expression in ACI. Things like drawing, things like image processing, design. So there is an overview of these tools are called CSTs, Creativity Support Tools. And the latest paper that is summarizing the design of creativity support tools in ACI was done in 2019. And if we look at this table, what we see is that the tools they analyze not only are at very different level of maturity. As a surprise, actually, 98% of these tools are no longer available. Like people cannot play with them, or they were just prototypes, or they were projects that were done for a paper. But it's hard, like, to actually build CSTs that last over time and people use in their day-to-day work. And on top of that, we see that each of these different projects, different CSTs, would target different levels and different category of the creative process. Some of them would focus on individual creativity, others like on collaborative creativity. Some of them were focusing on the pre-ideation or idea generation. Others were focusing on helping people implement projects. Others were focused on reflection, but it's rare to find tools that actually support different stages of the creative process. So this is what I found when I was looking at related work. And the other thing that I found, which is related for my study population, like because I work with young people, is that it is important to not only decide what level of the creativity process I want to focus on, or if I want to try to support all the different levels of creativity process in programming, but also to think about the age of my students, or I shouldn't call them students, of the young people I'm working with. There is something that is called an optimal fit, as defined by Barbot Batiste and Todd Lubbert, where there needs to be this intersection of divergent thinking that people are engaging in, the motivation they have for a specific project or task, how much knowledge they have in that domain, and the level of openness, both in the task and in the approach, and the learner approach to the task. So there are like many things that need to intersect in order to have like this optimal fit for creativity development. And I also found a couple of inspiring projects in terms of CSTs that, like I said, are not necessarily focused on programming for youth, but are inspiring for me in terms of their approach. Some examples are Gidget. So in Gidget is actually, this is programming, but it is the approach where there's only one right solution, and I would like to have a more generative approach. And in Gidget, what I like is that there is a character, there's a robot that is either lost or sick or needs to solve puzzles, and the learners need to change the programs in order to help this robot. So I thought the character development and the activity development was very well done. Other projects are Mosaic. This was actually done for sketching. And what I liked in Mosaic is that a lot of the focus in the tool design was on process. So people get to see inspiring drawings from a community of sketchers, but they don't only see the final outcome. They actually see the process. They get to see like, how did the sketcher created this drawing, like what did they start with, what do they do afterwards, and they get to remix these drawings and start like at different phases of the process. The other example I found I liked a lot is this application called Shadow Draw, and this actually is for tablets and mobile devices. And what I like here, this is, instead of being more of a support, this is really a collaboration. So when users are touching the screen, the system is kind of like trying to guide through shadows in which direction they could go and draw if they want to make specific drawings, like a bike. But there is also a mode where the system, kind of like in Drawdio, adds line as well. So you're not only drawing by yourself, but you also have the system that, based on what you're putting on the screen, will add new lines or will try to develop the drawings. So we are seeing there this direction, like how do we actually go from support to more of a hybrid collaboration with system for creativity? At which point, like, do we use this creativity systems just to teach us, and then we, like, once we learned a skill, like, we don't need them anymore? And I'm sure, like, Clippy comes to mind, right? And sometimes, if that's the approach, it can either be supportive or annoying, depending on how it is designed. Or do we see these systems as entities that are there and learn based on our activity how to collaborate with us in lots of different ways? So this is an open question. And the reason this is an open question is because systems today with deep learning and machine in the loop are able to do much more than before. So all of a sudden, we do see new opportunities of hybrid collaboration with AI systems that were not possible before. So why does this matter, and why do I care about this in the context of children and families? I care about this because children are growing up with AI. We actually have half of households in USA alone that have house assistants, voice assistants. So we have an entire generation of young people who are growing up with this assistants in the home already. And then it becomes a question of, are they just consuming this technology? Are they creating this technology? Are they collaborating with this technology, learning with it? And what I learned from my previous research is that initial perceptions matter a lot. So even back in 2017, when these technologies were just starting to be widely adopted by youth, we did a study where we had children of ages 6 to 12 interacting with lots of different smart devices and smart toys and chatbots. And we asked questions to see how they perceive these devices. And what we saw is, overall, children perceive most of these smart assistants and AI friends, AI toys, as friendly and truthful. But we also found that age made a difference in how they were attributing intelligence to the agents. So younger children, 6 to 8, weren't so sure if Alexa, for example, is smart, while older children, from the moment they were starting to go to school, most of the kids were saying it is smarter than me, even though they could ask 2 or 3 questions and kind of corner Alexa, so it couldn't answer their questions. They still thought it was smarter than they were, because it had access to so much information. And this matters because if we want kids to create with AI, program with AI, have critical understanding of AI, what an agent should say or do, it turns out that the way they attribute intelligence to these devices is at the base of all other attribution. If they think it's smart, they would trust it more, right? If they think it's smart, they would think it's more truthful. If they think it's smart, they would interact with it more. So this question of intelligence attribution is quite key. So, this surprised me. I was not expecting the majority of older kids to say voice assistants are smarter than they are, especially when they saw their limitations. So I wanted to explore this question further. And one, we use the same terms, like we use the word smart for people and machines, although it might mean different things, and it actually means different things. We use the word learning, like people learn and machines learn, but it means very different things. So I wanted to understand more deeply, what do kids mean when they say a robot is smart or a machine is smart? So I ran another study where I was trying to disentangle and better understand children and parents' definition of intelligence when they talk about robots. And for this study, actually, we had children and parents participate separately. And what we did was that we asked them to watch videos of a robot solving a maze, a mouse solving a maze, and then they got to solve the maze by teleoperating the robot. And for each of these conditions, we asked them to describe who was smarter in solving the maze. Was it the robot, was it the mouse, or themselves? And again, the children and parents did the study separately. But what we found afterwards was that both the parents' attitudes towards the intelligence of robots, for example, influence children's attributes. So if a parent would say, oh, the mouse is smarter because it is an animal, and animals, through evolution learn so much, and he needs to go and get the cheese, and of course he's going to smell the cheese and find it, then the child would actually have a very similar explanation, although they weren't doing this together or in the same room. If the parent would say like, oh, the robot is smart because it's more fluent, it's programmed to go through the maze, it has sensors, it can detect the edge, or it has AI, it learns from lots of different mazes, like how to do this faster, and it will do it faster than the mouse, then the child would also say like, oh yeah, the robot is smart because it's either AI, or because like it has like the computer tells it what to do. So this for me, was back in 2018, the reason why I started also working with parents, because I realized that it doesn't matter only like what children are learning in terms of showing them what the robot sees and how the robot learns and how the robot is programmed, but if the parental attitudes have such a strong influence, it's actually important to also inform the parents and have learning activities for the family, not only for the children. And I've been doing this workshops of children and families programming AI, programming smart agents, in lots of different settings. One series of workshops, these were longitudinal studies. So there was a study I've done in private schools, public schools, and community centers for 6 weeks. And what I found through this study, which was published last year at IDC, is that children's perceptions of machine intelligence, like is it smarter than me or not, actually changes once they get to program the Cosmo or the Alexa or their own smart game. And they become more skeptical because they understand like, oh, it's someone is programming, is giving examples of images that the robot is learning from, or the game is learning from. It's not magic. It doesn't have like the secret intelligence. It actually comes from data, or from data and algorithms. I also have done a series of international studies, both in Denmark, Berlin, Sweden, Chile. Not all of the locations are here. But what I found is in these international studies is that it's not just the exposure to programming that makes a huge difference, but there is also a cultural component. This is the programming interface they were using that I designed. It's Cognimates.me. It's free and open source. You can go and play with it yourself. And it allowed them to program things like the Jibo robot or the Cosmo robot, to play hide and seek with them. Or they could program, this is a 3D printed robot, it's called Ergo, and they could program it to draw from their examples, like showing them like, oh, here's how you make a sketch, and then the robot is trying to reproduce that drawing. Sometimes it makes mistakes, it's quite funny. The cool thing about actually programming an agent is that the agent can also help the kids in the programming task. So I'll show you what that looks like.
So let's do a program that allow me to learn it. Let's start with the green flag block. There you go. You did it. I need you to help me ask a question. We'll need the ask block. See if you can find it. Awesome.
And of course, not all the schools have access to these robots, right? So some of the features are available on the platform itself. Like you don't need to have a robot in order to have this sort of interaction with the agent you're programming. You could also have it with an avatar on the screen. What we found, like I mentioned before, after engaging in programming, the perception of intelligence changed. Like in the beginning, many more children were saying, maybe it's smarter than me, or yes, it's smarter than me. And after having several sessions of programming, smart games and training their own AI models and using them in smart games, we see that at the end, many more children said, no, it is not smarter than me. So we definitely saw that they became more skeptical. In terms of the cultural component for the international studies, we definitely saw a difference, even in the initial perception answers between different locations, right? So here, like we can clearly see the children in Berlin were much more skeptical than the children in United States. Shady Hill, EPH, ESCS are schools in US. And even then the children in Sweden, right? So there's definitely also a cultural component in when it comes to how we attribute intelligence to devices and how children attribute intelligence to devices, and how much do we trust these technologies. And that comes with exposure, media coverage, but also policy, right? A lot of the smart toys, for example, like my friend Kayla, are actually banned from being sold in Europe, for example, because their security was compromised, and they posed too much of a threat for young people. So I wanted to show you a quick video so you get to see how children describe this experience in their own words and how they think and talk about programming and smart games after they engage in these workshops. Let's see if this works.
So when we're programming robots, you can play rock, paper, scissors. You did rock, paper, scissors into the camera, and on cue you did one of the motions, and the camera did one of the motions, and it's like rock, paper, scissors, shoot. The computer gets like better as you play the game. Because like us, we might not know everything at first, but if we keep trying, we get better.
Everyone has heard about like machine-based learning or artificial intelligence, and there was a sort of no questions asked for a lot of the more tech-savvy parents. It's like, go for it.
Technology is going to be a huge part of their lives, much more so than my life. Is it scary for some people? It's AI and technology. I totally get it. But as a parent and as a teacher, I thought it was really important because these are skills that 21st century kids need to have.
When my dad was young, he bought a car and kickstart to see how it worked. So you teach people that know how these things that grown-ups mostly program, how it works.
So let me make sure I see. So yeah, so we see that even kids as young as 7 see AIs and programming smart games like the cars of their generation. And this was for us like very telling. Not only that they didn't think this was too difficult for them to do, or it was something that, you know, they thought like, oh, it was overwhelming or not fun, but they actually appreciated the fact that we exposed them to this technology, and they appreciated the fact that they got to tinker with it and customize it. So in the context, I mentioned that it is important to do this not only with youth, but do it with families. And right before the pandemic started, this is a series of workshops in person I was able to do with families at the University of Washington. So we actually got 20 families that came with their kids and aunts and cousins. Like, we had extended families coming to campus and engaging in a series of AI literacy activities, including programming. And what we found was that families really liked to have the agency, to be able to trick the AI, to be able to teach the AI, to be able to have control over, like, what is Alexa answering and why, or why is this app suggesting this drawing and how can I modify it, or how can I trick it, or even be able to design or create their own future smart assistants and design their personalities, their voices, their features, the type of support that they would get from them. And before doing this, we also asked them to draw, and we had like this big paper lying around. And we really wanted to understand, like, how do families talk about things like algorithmic bias, or what do kids and parents think like is inside Alexa? How does Alexa work? And how do they start to talk about this once we prompt these questions? And it was actually very surprising how little families had this conversation. Although they would have the smart devices at home, they never thought of asking their kids, like, oh, how do you think Alexa works? What is inside, right? So we see here, there was a child who actually drew the company of Alexa, and there are lots of tiny people inside, and they all have a task. One of them has to play a song, and the other one has to search the internet, and the other one has to find apps for games. And we also saw that kids had a very strong sense of fairness, like, what is it fair for an AI agent to say or to do, and what is not fair, even though not all of them knew what the word bias means. As part of these experiences in person or remote or online, I really wanted to understand more, like, how do we design learning supports, platforms for youth programming with AI, for families programming with AI. And the latest study I've done was with 15 families from all over USA, 10 different states, and also with a very diverse background. Our family spoke 11 languages on top of English, and very different levels of exposure to technology. These were not families that had a lot of experience with technology or programming. So we had a 5 weeks in-home study with these families and 11 learning activities about AI. These are some examples, like the families learn how to do image classification together by classifying images of corals or marine life. They learn how to summarize the images by selecting these anchors. They got to play games of scavenger hunt, like training an algorithm to detect specific objects and try to find those objects in the house. They play prediction game, guessing games. We had voice assistance activities where they were asking questions and comparing answers between family member and the assistant, drawing how the assistant works, but also designing, like, what the AI should do, what sensors it should have, playing bingo games or tricking the AI. So lots and lots of different activities. And as part of this study, we also created playbooks for families, where they got to learn more about all these different concepts of AI and AI literacy. And these materials are actually available and open sourced online at aiplayground.me. And what we found was that actually the activities that worked the best were the activities that were either physical, like tangible, that involved any sort of like paper or like more lo-fi technologies, or activities that were embodied, like where the family members got to program a game that would recognize their body motion, and they got to play that together. So the activities that worked best and supported most engagement and fun and learning for families were the activities in which parents and kids could engage in a variety of roles. They could collaborate, they could cheerlead each other, they could tinker, they could observe, learn, or teach, they could mentor. So the activities that supported the widest variety of roles were the ones that either had an embodied component or a tangible component. So I'm going to skip through this, and I wanted to leave you with a couple of questions, because I know we're getting close to time and I want to have time for discussion. I want you to reflect. I know I shared a lot of different studies and information and questions. Like based on these experiences, either of children programming AI in groups or programming AI with their families, you know, like how do we actually design systems? Like you have to think that all of these studies happen because I was there and a team of undergrads I trained were there, and like a team of researchers, right, was designing and supporting and facilitating a lot of these activities, but there's only a limited number of families that can get that facilitation, right? So how could we design systems in which learners, children, and parents could engage in directed creative coding with AI? So this is a prototype of a platform I'm working on right now, where you actually have a series of avatars that can support families as they're engaging in creative coding. So this is work in progress, and we're actually running studies right now with families and see how they use the platform. And then it's also like interesting to see what is happening in parallel, because I was talking about this going from creative support to a more hybrid collaboration with AI. What does that mean? And just yesterday, I wanted to share this, the US Copyright Office ruled that autonomously created art or works, assets that are done by algorithms cannot be copyrighted. And this is an example of the work that they rejected. So this painting was generated by an algorithm. The US Copyright Office decided like this could never be attributed to or copyrighted because it was done by an algorithm. So what does that mean, right? Like, what does that mean for how we will, like, our kids actually will perceive like creating with AI, coding with AI, learning with AI, and where do we draw the line? I know these are a lot of big open questions, but I wanted to close it there. I'm going to stop sharing my screen so I can actually see all the questions. Yeah, I know I bombarded you with a lot of information, and thanks for being here this morning and being patient with me. And I'm looking forward to your questions. Thank you very much.
Thank you, Stefania. This was an amazing talk. I have many questions, but mostly I'm so impressed by your work. I would like to invite the audience actually to pose questions. You can do that in the chat and then I'll read them out for you, or you can just unmute yourself. But yeah, I'm just going to give a few moments for people to ask some questions first. So I'm going to read the first question by Ida. Have you considered working with children with developmental disorders like autism? Some use tangible programming to teach coding for this population. I think that would be a great contribution to making coding accessible for all. Stefania, you're muted. Sorry.
Thank you. Ida, thank you so much for your question. Actually, UW has a long tradition of doing research in accessibility, including with children with developmental disorders. So I have great colleagues at the information school who are doing work in this space, not necessarily focused on programming, but more focused on different forms of learning and literacy. But yeah, I think it's a great idea, and I should reach out to Anushka, for example, who recently graduated and is now a professor, and kind of brainstorm. I also know there are people at Media Lab. Actually, when I met Patricia at IDC in 2017, my colleague Nikki from Media Lab was presenting her work on tangible supports for children who are on the spectrum. And it's not something that I have enough expertise in, but I can definitely collaborate or work with people who do have this expertise and just maybe tell them like, here's like, here are the supports I developed or activities or the platform. Would this be helpful, or like, how would you like to adapt it? But I think that's a great idea. Thanks for asking that.
You're getting a lot of good reinforcement too. Any more questions?
I see Lane. Hi, Lane. I see. I see Lane. Oh, I love this reflection. Elaine was saying she wonders how to create prompts in everyday activities in public spaces to support family engagement. For example, in laundromats, bus stations, and so on. Yeah, I love that idea. I really do. I know there was in New York at some point a project for family literacy in laundromats. Like they put books, and there was this entire project for literacy in public spaces, but not so much focused on creativity, right, or creative prompts. And I think actually having a good prompt goes such a long way. I'm sure you know that already. Lane does work and research in this space as well. And one of the trickiest part right now, actually, for the system I'm building is like, how do I automatically design these prompts, right? Like depending on what type of coding project that a family starts working on, how do I automatically generate prompts that are good and don't limit what they do, are not confusing. But this is a much simpler solution. It doesn't need to be on a computer or on a tablet or on a phone. It could just be in a physical space, right? Yeah, we should talk more about that. I think it's something so simple and cool, and I would love to brainstorm more and think more about it.
There is a question by Jen. In your experience, what are the current barriers to bringing these kinds of learning experience to more classrooms? Great question.
Thanks, Jen. Yeah, this is the biggest question, right? So I've been doing this work since 2016 until now. The access to technology and the infrastructure of classrooms has evolved, but not as much as one would think. And even now, because schools, opened up, and I'm itching to do workshops with kids and families in person. I reached out to a series of schools here in California, in San Mateo. I'm discussing with the directors, and it's quite tricky. It's quite tricky to still get access to, computers or reliable internet, and we're, I'm talking about California, right? That has more resources than other states, for example. And not to mention, I'm originally from Romania, from a small village. Like I've worked with kids in schools or different parts of the world, like very, very different economical like situations and equipment for the school. So I think it's definitely tricky even today in 2022 to reliably have access to computers and to internet in schools, because as Jen also does work on AI education, or not only education, like tinkering with AI. And as we both know, there are a lot of requirements, right, to load the model or get the predictions. Like you actually need to have quite good internet connection. And for Cognimates, when we were designing the custom training, this was one of the hardest things. Like, how do we actually do transfer learning that works fast enough and reliable enough that would not be too slow on a school connection, right? Because if a child has to wait for 10 minutes for the robot to talk back, then it's not going to be fun, right? So I think it's definitely a challenge the moment we want to have fast responses, engage with like the most state-of-the-art models, if we don't have reliable internet connection. At the same time, some of the examples I showed of like lo-fi or paper-based activities work pretty well. And I was collaborating with this organization called Curiosity Machine that have been doing curriculum for AI literacy for families all over the world. And most of their curriculum and activities is lo-fi, right? So they're learning about neural networks with tangible materials, with tangible learning supports. So that's probably a way of crossing the gap in terms of infrastructural needs for now. that being said, I do hope that schools and overall like will get more support in terms of infrastructure, because there's only as far that we could go in terms of these tangible or lo-fi learning activities. And at some point, most of the kids would want to like do the real thing, right? And I don't have a solution for that. Fund, put more money in education, right?
Yeah,
So
that's a great reply, Stefania. And I love the concept of the lo-fi technologies you mentioned, because at the end of the day, children really want to feel comfortable and even be able to break things. And I think that just translates so much of how they interact and learn with the world. There is one more question that I really love by Matthew that I would like to read for you. Do cultural contexts internationally or between different community contexts change the required approach to learning about AI for families and children?
thank you, Matthew, for this question. They definitely do. So when I was working with families in Germany, for example, I had to do much more work even before we were doing the activities to really explain to the parents like what exactly would happen, what data is being recorded, how they can opt out, why we're recording the data, how we're going to use the data for writing a paper, for example, how it's being anonymized. So there's much more sensitivity just in terms of data privacy overall. And in terms of AI, I saw like for some of the devices, like the families or the kids, they didn't want to interact with some of the devices, right? And reassuring them and making clear like not all of this is optional, and if you don't like, you know, to talk to this voice assistant, or if you're offended, like one of the things we discovered in the most recent workshops I've done in Germany, we saw Alexa just released, was released to be able to work in German. So the families would test interactions in English because they spoke English too, and in German. And, you know, it would answer to German questions, but completely miss the context, right? So you would ask about the woman doctor and you would only answer about the male doctor, or you would ask about football and he would tell you about soccer or things like that. So there's still a lot of work to do in terms of the models that are being used in different languages, the lack of data, how tricky it is for these models in general to recognize kids' voices, but in particular in other languages than English. So one thing that I had to change a lot in my approach internationally is do a lot of explaining, making sure people are comfortable, but also listen, like just asking them, like, what do you think about this? What are your concerns? You know, why are you interested in it? But at the same time, like, you know, would like to really control or be able to mediate like how your child is interacting with this technology. So I think for sure it takes adaptation and preparation for each country. And you know, meeting people where they're at. Like luckily for me, I speak a lot of languages, so when I go and do these workshops, most of the time I can do the workshops and activities and everything in native language with people, so that helps a lot. And just change it, like be flexible to change things. If you prepared an activity and you see that people don't feel comfortable, don't like it, say like, you know what, like let's do something completely different. Like what would you like to try, or like why do you want to try this? Because at the end of the day, I care much more about families and kids having a good experience and really understanding where they're coming from than collecting data for a study. That's always secondary. So yeah, I think we need to have much more work in international context. If you actually look at CHI and IDC and all the work that's been published in terms of child agent interaction, family agent interaction, a lot of it is very focused on English speaking language regions. So I think there's much more need to understand the cultural differences, to understand the different approaches. And I hope many of you here will, will join me. I know there's a very diverse team organizing the seminar in doing this work, because it requires a lot of adaptation.
Nice. We have time for one more quick question. Sylvia, I saw you had a question. Do you want to quickly speak by yourself?
Yes, but actually, like this reply you gave also made me like come out with other questions. So I don't know, maybe we can move them directly on Slack if you want, because I think I have another one after, so we have very little time. And but it was really good. I really enjoyed the talk. And I think what you were saying now, it's extremely true. Also because sometimes we are pressed by the idea of collecting data and forget that maybe changing the activity or maybe like focusing more on the experience would make us arrive to even more knowledge about something. So it's really cool.
Yeah. Okay, so that's a good idea. Let's move the discussion to Slack because there is more questions maybe too. You can find the link in the chat. And I want to invite you all to thank Stefania for her time and answering questions and just being here early in the morning in Berkeley. Hopefully there's sun there too. Thank you, Stefania. Your talk was amazing. And I'm just going to take one very fast minute to introduce the next speaker for the session of Talking Robotics. So next, in 2 weeks, actually, not next week, we will have with us Pratap Totekar. He's a professor at the University of Maryland, and he will talk about near-Earth sensing with aerial, ground, and marine robotics. Again, we want to thank our sponsors, Animata, Semio, and PAL Robotics for all the help with our infrastructure. And thank you all very much for being here. I wish you an amazing week and an amazing day.